Thank you so much for being here today, for joining us at GitHub Satellite. Personally, I'm super excited about the keynote, and I hope that every single one of you found something really exciting in the keynote as well. So I want you all to take a moment and think about the last time when you made a change in your lives. Maybe it was a small change, like maybe you had some pretzels this morning instead of the usual cereal cup. Or maybe it was a really big change, like changing your job or having a child. No matter of the changes that we make in our lives, big or small, they have an impact on our lives. So what if, when you make a change in your life, you could firstly try it out, see how it goes, learn about the side effects, and then make it happen when you know it's going to be fine. I will let you think about if you want to do that in your life or if you prefer living your life as it is today. But in the next half an hour, we want to talk to you about how we make changes in the software projects and the lessons we learn from making changes in our projects. So there's over 100 million repositories on GitHub. So this means that we and every single one of you have tons of opportunities to learn from these projects and from their practices. And today, we want to share with you some of the lessons we learned from some of the open source projects on GitHub and from some of the enterprises in the way that they do automation, continuous integration, and continuous deployment. My name is Simina Pasat, and I'm a product manager here at GitHub. And I used to work in the developer space for the last years. I worked on services for gaming in Xbox, I worked on mobile developer tools, and now I'm so excited to join GitHub, the home for you developers. And as I was walking here today to the venue, I was so happy to see many developers who make GitHub what it is today. And also many of our partners, people like Travis CI and companies like Circle. Without them, GitHub wouldn't be what it is today. I'm so excited to have here today on stage one of our cool partners, Jamie Cool.
Thanks, Simina. So Simina told me about 10 minutes ago backstage she was going to introduce me with a cool joke. I just kind of smiled and nodded politely. Yeah, I've heard that one a few times. So I've been at Microsoft now for about 20 years, and yeah, I know that's a long time. Most of that time I've spent in the developer space in one form or another, whether it was the first version of the .NET framework, Visual Studio, but more recently, I've been building services for developers. One of those services is a CI/CD service. Last month, we did about 30 million different builds and deployments. Our customers are all types, whether they're external customers or whether they're internal customers like Azure or Office, whether they're small customers or whether they're large customers like Windows, who has somehow a 400 gigabyte Git repository for their source code. And in the process of this, I've seen kind of more change in the CI/CD space in our engineering systems than really any other place. And I've seen the degree of impact that makes. I've also seen and experienced, in many cases the hard way, a bunch of the lessons of what doing it right and doing it wrong can mean. So I'm excited here to just share some of those learnings. So Simina, why don't we go ahead and get started?
Thank you for joining us. So before we jump into the lessons learned, I want to take a few minutes and really get us on the same page with what CI/CD means and what it means within GitHub. As you know, it all starts with code and coffee for some of us, but mostly code. So as we work on our code, at some point we think our changes are good to go. And then the fun begins. We want to make sure that our tests are passing, that the builds are green. And when everything looks good to go and our teammates give their thumbs up, we are ready to deploy our changes. It's good to firstly deploy them to a staging environment, to a testing environment, where people in our teams can try things out, see how it goes. Maybe we have a QA department. And when things are really good, we are ready to try them and test them. We're ready to put them to production. When we're in the production, we're not done yet. We have to validate and learn, and to make sure that what we shipped is working properly, that we have the right monitoring in place, that we listen to our users' feedback, we catch bugs early, we listen to our support channel, and as you know, the list goes on and on and on. Also, the fun doesn't stop there, because as we learn from our customers, we're back to the coding stage, and it all goes in a loop. So I want to take a moment and think about what build and deploy means at GitHub. At GitHub, we always believed in the power of the ecosystem and the partners around us. And even back in the early days, we opened up API endpoints and webhooks. And from day one, we were amazed to see all the great integration and experiences that were enabled for our joint customers. But no matter how great these experiences were, there was a big problem. People couldn't discover them. So we have done what everybody was doing, introduced the GitHub Marketplace. In the GitHub Marketplace, it works like any other marketplace. Publishers publish their apps, consumers come to the marketplace, browse what's there, they decide for the best tool for them, and they start using it. That was great, but the journey continued. We also learned that our customers, our developers, wanted to stay in GitHub for as long as possible and not change context from one place to another. So we introduced rich integrations, things like the checks API and the check status. So developers could use GitHub to start to rerun builds, to see the code annotations and all the details within GitHub without leaving the interface. The journey continued, and just last year at GitHub Universe, which is our fall conference in San Francisco, so at GitHub Universe, we announced GitHub Actions. GitHub Actions was more than CI and CD. It was repository automation. And over the last 6 or 7 months, we were absolutely amazed and humbled to see all the ways you developers took GitHub Actions in your own workflows, and to see how our partners and integrators took GitHub Actions and put them back on the marketplace in new workflows for our joint customers. So I hope now we pretty much all talk about the same thing when we talk about CI/CD. So let's go and see the first lesson that we have.
OK, so the first lesson is an amazingly deep and insightful one. So it starts with doing CI is a good idea. OK. Now, I'm willing to bet that most of you in some form are already doing CI, but CI comes in a lot of different forms, right? So from the simplest, and let's call it Bob CI, and that basically means every once in a while, Bob will do a build using the machine under his desk, and then you deploy that, to every night, you'll have an automated build that will run, to every time a change goes into the trunk, you have a CI build that runs. That's getting better. To every single change that, before it gets into the trunk, has CI and automation run. And you're getting a lot better now. But then you're getting to the point of, are you running all of the right automation as early as you can in all of the right places? And really, the core of the lesson is, you want to be running as much automation as early as you can in the process. Because the earlier you run the automation, the higher return you're going to get, because you're going to find these checks simpler. And GitHub really has fundamentally changed how this works. So the first time I saw pull requests 10 years ago at this point, I thought, it's another tool to do code review. That's nice. We already have kind of code reviews, but this is a nice version. I was wrong. I didn't get it then, right? What pull requests really are is the workflow for your developer, right? And that workflow lets you seamlessly integrate things like CI and CD into the daily lifecycle of the developer. So before we had pull requests at Microsoft, we had literally dozens of internally built systems that were all different versions of what we called gauntlet systems, because you had to run the gauntlets before you could get your change into the trunk branch. And all of them were taxes, right? They were these separate tools you had to go and do, and that's kind of the name, running the gauntlet. But with pull requests, it is essentially this valuable thing. And the thing about it is the more automation, the more you tie to pull requests, the more valuable it becomes, not just for the organization, but for the developer himself. We see people all the time at Microsoft, they will go in and create a pull request just to have the automation that is tied to that run before they even submit it to get changes reviewed for it. The nice thing that GitHub has really done well, in my opinion, is make it seamless to integrate in. So I mentioned that with our system, we do about 30 million builds. A large number of those are builds coming from GitHub repositories. And via all of the extensibility that Simina was talking about, things like checks, where it lets us as CI system publish back information about the build into GitHub, they can then seamlessly display it as part of that developer workflow. So here you see a pull request looking at the checks UI, and this checks UI has a whole bunch of different services from CodeCov, Travis CI, Sonar, Azure Pipelines, all pushing data back that get integrated into the actual pull request. And then here in this visual, you can see in the actual conversational flow, GitHub is giving you information about not just the people that are reviewing your code, but essentially the systems that are reviewing your code, and making that a seamless part of the workflow. And really, this makes it something that there's no reason not to take advantage of it. There's no reason not to go and do it, and it's basically a good thing for developers as opposed to a tax. The other thing that this does is it really enables shared contribution across both open source and enterprises. I can't tell you how many times I've been in situations where Team A needs something from Team B, and Team B is too busy to do that thing for Team A, and thus conflict arises in negotiation and all this kind of thing. Team A would be happy to go do the work for Team B in their code, but they can't because there's too many obstacles in the way. The biggest thing I've seen is that once you start to have automation, CI/CD in place for this, it unlocks that, because as soon as you have automation that allows you to know that the change you're submitting is actually going to work and not regress you and not take you backwards, it makes you as the team trying to contribute it more comfortable doing it, and it makes the receiving team more likely to be willing to take it and unlock it. And I see this across the enterprise, I see this across open source. Even at Microsoft, one of the big initiatives that we've had internally with our engineering systems the last 5 years has been to try and move towards a dynamic where the culture of the company, the culture of the teams, is much more about a similar one to the open source one, where teams are empowered to be able to make those contributions. And CI/CD is a big part of that because it helps enable trust. So Simina, you have any other tips about helping to enable trust?
I do. As I was saying, there's tons of repositories on GitHub. So as a repository owner or a maintainer, you want to find ways to quickly communicate to the repository viewers what the repository is about. And as a developer, we want to be able to quickly go to a repository and understand what is that repository about. If I want to use a library, I want to make sure that the library is something that is actively maintained, that it has a lot of downloads, that there's a secure library, because I will take this dependency for the many years to come in my project. And README badges are a great way to achieve that, because they provide to first-timers, to first viewers, and to old-timers quick details about the repository. So let's look, for example, at React Native. This is one of the most popular projects on GitHub. What it means is that there's also a lot of people who are looking at the project, they want to use it, and they want to contribute on it. So React Native has a few badges. Some of the notable ones is that they welcome PRs, that's great. Even better, they're under MIT license. And if I'm interested to learn more about them, I can also follow them on Twitter. But even more, I can also see that the builds are passing, and this is a package, this is a open source project that is actually getting maintained. Another example is Pandas. This is a data analysis library for Python. And here we have the same details, but even more, we can see that there's over 4 million downloads that happen for this library. So if I decide to take a dependency on it, I have pretty good trust that people are going to maintain because there's so many other repositories and people depending on this library. I can also see that the releases are on PyPy, so I can quickly go to PyPy and download their latest release. And I can also learn that their builds are passing, and they also have a pretty good code coverage, 91%. So now a quick story about badges. I used to be a scout for many years in my life, and I used to collect badges. I had like 15 badges on my shirt. I can still remember it. There were 16 in total, and I was missing one. But the bottom line was that I was so proud to wear that shirt because everybody who was meeting me could see what are my achievements and what I can do. And it's the same thing when you put up badges on your GitHub repository on the README. So I hope that you will go home today and put some README badges on your repo. All right, Jamie, what's next?
So one of the big kind of changes that has happened inside of Microsoft over the last 10 years has been going from a server company where we ship servers to customers every 2 years, hopefully every 2 years, didn't always work out that way actually, to shipping a service, to becoming a cloud company. And that's driven a whole bunch of change in terms of our engineering system and a whole bunch of learnings. One of the things that we are always trying to identify is like, what are the things that we can do that will make the biggest differences in our ability to ship fast? And the thing that we found is that nothing is more indicative of how fast you can ship to a service as the time it takes you to validate that a given code change is not taking you backwards, is not regressing you. Because if you know that is true, then you can decide how fast you want to ship that change out as you want. But if you're not sure it's not taking you backwards, then it's going to slow you down. And in order to be able to achieve that, you've got to invest in your automation. It's got to be fast, it's got to be reliable, and if it's not, it actually becomes counterproductive. So let me tell you a story of testing. So when I first joined Microsoft, the way testing worked is we had a test team. Test team was a bunch of manual testers. So we would author this big test plan when we were doing a feature, and then the feature would get done, and then the test team would go through and run through this test plan. They'd file a bunch of bugs, we'd fix the bugs, they would introduce new bugs, and we'd repeat the cycle, and we'd go back and forth as part of this. And we realized this probably didn't work very well. So then the next phase of testing is we brought in a whole set of automated testers. So this was, again, still a separate test team, but they would write a bunch of automated tests. And the automated tests that the test team write, were very large, very complete test systems. They typically were functional tests, which means they were top of the stack after you deployed it, that set of things. And then we tried to move to the service world, and really what you want to be able to have is you want to be able to have a reasonable set of tests run before the changes even get checked in the master. So if we take those set of tests that we have and you try to put those then in the way of the engineer being able to get their code into the trunk branch, turns out you generate a lot of conflict because if those tests aren't fast, and they weren't necessarily fast because UI tests aren't always fast, functional tests where you have to deploy things aren't necessarily fast, they also tended to be flaky because of all those same sets of things. And then you would get a revolt because you basically put obstacles in the way of the engineering team that they weren't bought into. So now the way it works is the engineering team is responsible for quality. They're responsible for all of the testing. And a bunch of products have gone through journeys like mine have gone through, where we took those test suites and then we intentionally went through and you refactor it. And you pull it down to the set of things like, we call them L0s, but basically unit tests that are very fast, very reliable. And we have tens of thousands of these. They take about 4 or 5 minutes to run typically. Those get run on every single change as part of our PRs. Then we have a set of other automation that you do want to run. There are functional tests that you want to run once the change is a little further in the progression. And you decide where you're going to put each of these sets of things, so you decide where you're going to pay the price in terms of speed. So investing in your automation, deciding where you're running what set of operations, and the earlier it is in the life cycle, make it fast. The other thing you can go and do is you can throw compute at it. So compute is cheap. Compute is getting cheaper. Developers are expensive. Developers are getting more expensive. So anything you can parallelize, you should parallelize. So whether you use my product, or whether you use another product, Travis or Circle, or AWS even, or Google, you should pay them money. You should buy the compute. Anytime you do the math and you're there looking like, yeah, do I want to spend an extra $1,000 on compute? Then you do the math of like increased productivity for your developers that you're paying, how much more times how many developers that you've got. The return is almost always there. So here's an example. This is the VS Code build. The VS Code build, they need to build in Windows, Linux, and Mac. You could go and serialize that, or you could just throw 3 machines at it and do it at the same time. Here's another one, libgit2. Libgit2 also needs to build on multiple operating systems, but has a bunch of different flavors. Go throw machines at it, go do them all at the same time. If you've got 40,000 unit tests, and all of those can be run at the same time, go through machines at it and parallelize it. It makes a big difference. Like we have at Microsoft, we typically, we'll have builds like the Office build, take 4 or 5 hours. Unless we put 25 machines on it, then it takes a lot less time to go parallelize it. It makes a huge difference, and I can tell you the difference in the morale of the team once they've gone through that process makes a huge difference. Another lesson is automate everything. So we talk about CICD, so this is build. We're typically talking about build, talking about test, but it doesn't have to stop there. So the first time the product that I work on moved from being a server product to a cloud product, essentially, the deployment mechanism for doing that was to go have Vlad run a 25-step document to do the deployment. And Vlad was exactly the right guy to be doing that deployment, but it didn't always work reliably for obvious reasons as part of it. And then once we started to deploy to multiple data centers, and you had to repeat it in different forms, that became much more of a problem. And so we went through a process of investing a ton to get not just test automated, deployment automated. And we didn't go from 25 to fully automated overnight. It was 25 steps, then 10 steps, then 5 steps, then 2 steps, then 1 step. And I think that's a really good approach to help you get there with all these things. Is if you try to go from where you are now to the final state you'd want to be at in one huge step, like odds are you're not going to have the organizational willpower to go do it, but you need to find a way to get there. The other thing this lets you do, though, is once you have deployment automated, it lets you continue to pull automation earlier into the life cycle. So here's an example. So this is just a dashboard I pulled off of the engineering system that we use. And what happens here is anytime a change hits master, we will go and we will deploy all of the microservices that are part of that particular service. And then we will run the functional test on it. So these tests take a little longer. These tests will usually take 20 to 25 minutes to fully go do this as part of it. And there's a whole suite of them. So each of these rows are a microservice, and each of the columns are a build. So if you get a column that is all green, then this one has had like that full set of functional tests running as part of it. So what this means is that the developer, once they get a change in the master, we know about half an hour later whether this change across all of our services is in a state that we could deploy now if we wanted as part of it. And this used to take days before for us to really go and do. But because we got all this automated, you can pull all of this earlier and earlier in the life cycle. The other thing that you can do with this is that the developer is now empowered. So if the developer wants to do a full set of tests here, even though it takes half an hour, they can go and opt in and do it. And a lot of times they'll do that because this is a bigger, more disruptive change as part of this. So the other thing, and I mentioned before that our deployment started to break down as we got more complex topologies and we started to deploy out, is you can have automation, and even if you have to deploy to 4 environments, you can know that if it deploys to those 4 environments, it will deploy reliably, it will deploy the same way, which is good, because if I look at the actual matrix that we have for my service, we deploy to about 20 different data centers all over the world, and each of these go to different rings. So we'll deploy to ourselves first, then we'll deploy to a bunch of other internal customers, we'll deploy to early adopters, we'll deploy to the US, we'll deploy to Europe, and it'll go through each of these rings of data centers as part of it. And each of these, you can see kind of the dependencies and how we do it, but because all of the deployment is automated, we know it's going to reliably work the same way on each of them, and it lets us then have control to manage the life cycle of the change, whether we want it to roll out in an hour because it's a change we have to get out because it's critical and we want it to go fast, or whether this is a big disruptive change and we want it to roll out and let it bake for half a day before we roll it out to the next ring and next ring and next ring. You have that control. So this is an example of services and how you can go do this, but Simina, people are really building all different types of applications.
That's right. There's not only servers there that need to be deployed to 20 different data centers. There's also things like packages and libraries. And if you're building a library, then you have different needs. And different needs have different solutions. And there's no two single projects that have the same solution. There's no one-size-fits-all when we talk about automation. So now let's imagine that you're a maintainer, or maybe you really are a maintainer working on a library. And what you want to do is to get your changes pushed to a package registry so that any of your consumers can download the new package. There's a lot of package registries out there. And today I want to talk about one of them. 2 weeks ago, we announced GitHub Package Registry, which is a package management service for developers and teams where they can push public packages and private packages next to their source code, next to their repositories. That means that for developers and teams, they can go to GitHub and decide what are the right packages that they want to use in their projects. So you can sign up for the beta, and you can check out all the details and the features later. But today I want to walk you through one example of a team that has a specific workflow. For them, the master branch is a source of truth. This means that whenever something hits master, they want to package everything and ship it to GitHub Package Registry. And to do that, they will use a GitHub action, which listens to an event that says, hey, a PR was merged, and will start packaging everything, publish it to GitHub Package Registry, and then comment back on the PR. All right, the video is working. Great. OK, so this is the action. Now let us make a small change in the package JSON so we can see how this action is working. So I'll make a small change in the description. I use an example of a library. It's called PKG Cloud. It does a bunch of abstractions for different cloud providers. So I will say this is an awesome library. I will change the version, the min version in this case. And I will create a new branch. And this will open a pull request. So I'm proposing the change. I'm creating a pull request. And now, in real life, as Jamie told us, we're going to have some CI, some unit tests. We're going to have a bunch of our teammates giving us great suggestions about how we can make our changes even better. And finally, we're going to merge the pull request. Now, the GitHub action has picked up the event and will start the workflow. So the GitHub action detected that there's a new event to merge the PR to master. And it will start different builds. It will package the library, and it will get it ready to be published to GitHub Package Registry. When the package is published, anybody with access to the repository can go to the package details and start installing the package. So in this case, the action is still running. And once it's published into GPR, it will comment back to the PR. So this is an example for an NPM package, but GitHub Package Registry also works for Docker, NuGet, Maven, and Ruby. And there's more coming, so we encourage you to try it out. So OK, in the meanwhile, the action is finished. It completed. So if I go back to the pull request, the action has posted back to the pull request so that every contributor can see where the package is located. And here on the package detail page, they can see how to install the package, what are the details, number of downloads, and also those README badges that we talked about before. So the bottom line here is that no matter what service or package or type of library you're working on, and no matter what type of tools you're using to publish it, the important part is to customize your workflows based on your own needs. So I know there's lunchtime soon, so let's do a quick recap, and then we can all head out to lunch. So the most important lesson that Jamie told us, thank you, is to start doing CI. So start small. It's not going to be easy, we know that, but it's really going to pay off. The easiest lesson from today is to use README badges. It literally takes a few minutes to do it, and you will see the benefits yourself. And then once you start doing that, we encourage you to make everything faster, to iterate on things, to ship the value to your customers, and to learn from them. So with that, I think we're almost done.
Yeah, I mean, we had half an hour to talk about CI/CD. That's kind of not enough time to go deep on much of anything. So I guess I would just leave you with one thought. You know, if you're not to a place where you know you have the CI/CD system that you want, like to the maturity level that you want it to be at, but you just haven't found the time to go invest in it. And I see this all the time. People don't find the time to go and do this because it's not feature development, it's kind of ancillary work as part of it. I see them not do it, and I see them get burned. I see them get burned in terms of quality. I see them get burned in terms of not being able to move fast to the degree they want. In my experience, nothing else makes as high a return on investment as making sure that you have the automation in place for the product that you're working on. So with that, I think we're ready to break. Simina, thank you very much for having me here. And if you have any questions or comments or concerns, Simina and I would be happy to answer them.
Thanks.
Thank you.